So in this problem, we're told that there is an entire test that's done and that they found that there's a correlation between two different quantities and that 0.60 is the correlation coefficient. And the two quantities that they related are speed and damage. So those two quantities are related in some way, and it makes sense. If you crash into a barrier at a higher speed, there should be more damage. So as speed goes up, damage goes up. Now, if the speed at which a car hits the barrier is 1.5 standard deviations above the mean speed, so this is going to be important here, 1.5 standard deviations above the mean speed. As a reminder, because they use standard deviation as a measurement, we can call this a z-score. What do we expect the damage to be for the mean? Well, to illustrate this idea, I have this understanding that if you talk about a line, and it's a perfect line as far as a regression model is concerned, a correlation of 1 would mean that if I start right here at 0, 0, and I move 1 unit this way or 1 standard deviation this way, then there should also be a change of 1 standard deviation in the other direction as well. But what happens here is this standard deviation or the correlation coefficient in red right here is saying that this particular line has a model where for every 1 unit of standard deviation of change on the x variable, there's not 1 standard deviation going in the other direction, but instead that it's about 0.6. So what I'm going to do here is I'm going to say, okay, well, if speed increases by 1.5 standard deviations, then that means that the damage should increase at 0.6 times that rate of change. So if I take a look here, I would say 0.6 times 1.5 on my calculator, and I get that this calculation right here is 0.9. So we would expect the damage to be 0.9 standard deviations above the mean. And the reason it's above is because the speed went above, so therefore the damage should be above average damage. And that is how we get our answer of D.